Yep. Okay, everybody, how are we doing? Good? Okay, thank you for joining this session today. My name is Angela Caicedo, and I'm an Oracle Evangelist. So I've been working with Java for quite a long time now as an evangelist, and what I like the most about Java is how much fun you can have with it. I mean, I can't believe, if you joined us at the university sessions that the evangelist team from Oracle did, we build Legos. We build Lego, and we play with them, we program them, and they pay me for that. So I can't complain. So the idea of this particular presentation is I'm always looking at what is going to be my next demo. What I'm going to be spending the next few months that I can have fun, but it's still related to my job, right? They still pay me. So anyway, we're working really hard on embedded, how we can really connect this Internet of Things, how everything can really get connected with each other. And when you think about small devices, we start thinking about some constraints, about memory, how powerful these devices are, and stuff like that. And for me, it's particularly important that the things looks good. So even if I go to embedded environment, I want to be able to have a nice UI. I want to invite the people to really have a really nice experience with the user interfaces. So what I end up doing is I use a Raspberry Pi, and I build my own tablet. So I know it doesn't look as fancy as the Duke Pad, but this has been my progress from the last year, where I have a screen, and I mount a Raspberry Pi on the back, and I can actually create a very fancy application. So the first thing is like, okay, I have my own tablet, extremely cheap. It is so cool that my little ones, I have two little girls, and they're 5 and 2. And unfortunately, both of them love the iPad. So when I saw it, it's like, Mommy, Mickey. I'm like, no, honey, this is not for playing. This is Mommy computers. So anyways, it's good. So the idea with this is, okay, I have a Raspberry Pi that is powerful enough to run either Java SE or Java ME embedded. What about making something nice? So then you start thinking about, okay, the Raspberry Pi has all these available pins that actually are able to talk in different ways. So they support multiple protocols. What about starting connecting like different sensors and having something fun? So this is what actually come up with this particular presentation. So what about using things like accelerometer and gyroscope to really use the device positioning and do something nice with the UI? So I want to have a powerful UI, really where the user can really immerse themselves into the UI. So we attempt to think about 3D, but I didn't really want to have 3D on such a small device. I know Jasper and the FX team at Oracle has done an amazing job running 3D on the Raspberry Pi, but I was looking into, okay, what about a lower kind of, like a simpler kind of UI that I still can use the position of the device, but have a more simplified UI. And then I start looking into parallax effects, things like that, and this is what the talk is about. Oh. Sorry, guys.
You can blame me for doing pre-setup on the demo.
Okay, so that's pretty much what I've said. Why this particular talk and the inspiration for it and how I put everything together. So I'm going to do a small introduction. So I've been playing with the Raspberry Pi for quite a while now, using different protocols. So pretty much there are gyroscopes and accelerometers that use different protocols. In my case, I select one that was using I2C. The only reason for that was I haven't played with I2C before. So that's why it comes into a picture, hey, let's try this protocol, how well it works with the Raspberry Pi. The good thing is once you have I2C, I start finding all sort of devices that actually use that protocol. So for example, the Motion Plus, device is actually I2C device. So eventually you can plug one of those to your Raspberry Pi and has a really accurate positioning information. So, you start finding out that there's a lot of cool I2C devices. I'm going to talk about how to enable it on the Raspberry Pi. The funny thing is, when you looked at the Raspberry Pi specification page, they say, oh yes, there are SPI and I2C enabled. So they do support that. So you expect to connect the sensors and you right away is going to get some sensing information. Well, guess what? It doesn't. It doesn't even see the device. And I found, digging into what was going on, it happens that the Raspberry Pi has a blacklist. So if you are in the blacklist, you're not going to work. So you have to take those out from the blacklist to be able to enable to your device and sort of things that you have to actually do before you can actually use I2C on the Raspberry Pi. So it wasn't really straightforward, and that's why I want to cover it. The hardware that I use, I'm going to talk about MPU 9150. The only reason I use that board, it was because I have a lot of functionality in just one particular board. So I have an accelerometer, I have a gyroscope, I have a temperature sensor, and it also has some other information about positioning. So it's actually a pretty good hardware piece. It was a little more expensive than the normal. You can find accelerometer for $7, but this one was $50. It's still expensive if you compare that you're using a $50 sensor with a $35 computer. So, but I mean, for what I wanted to do, I really needed something like that. For the screen, so I used a Chalkboard electronic screen, and I will talk a little bit more about it. You might be already familiar with that. We talked with them, and they gave us like 10% discount code. So if you own a Raspberry Pi and you want to have a screen with it, so instead of having to plug it into your TV screen, you can actually get one of these nice screens. They're actually touch-enabled, so we're going to see that with Java, we can also have touch functionality. Then the software. So we know that Java runs on the Raspberry Pi. So you can either have Java SE embedded or Java ME embedded. So the first question is, which one should I take, right? When you look into Java ME embedded, you have a great functionality, a great set of APIs that is called the Device Access API that allow you to easily connect to peripherals. So because I was thinking into connecting sensors, that's like the first thing that comes to your mind. Oh, I can use Device Access APIs and I can connect to I2C, very easy to communicate. But the problem with that is I won't have a nice UI. I was looking into something powerful, like for example, being able to use JavaFX. So that's why I moved from Java ME embedded to, okay, I really need, because this is going to be focused on UI, I really need to have a nice UI. I really want to use JavaFX. So the backdrop of using Java SE embedded today is I didn't have those nice APIs for accessing those devices. So for working with I2C, I needed a solution. Fortunately, there is a very nice library called Pi4Java that allows you to connect peripherals in a very easy way. So that's what I ended up using. So I ended up using Java SE. I ended up using this particular library, and things worked pretty well. And then I used JavaFX for the interface. So again, for the hardware, we're going to be using the Raspberry Pi. I think pretty much you're already familiar with the Raspberry Pi. You might even own one. And again, we have this beautiful set of pins here that allow you to connect pretty much anything that you wanted. So we're going to see how we actually use it for the I2C. Again, this is nothing new. It's been around for a while, and we're seeing people connecting the Raspberry Pi to the coffee machine to get the coffee ready whenever they send a message, which is, I'm Colombian. I would love to have one of those. You know, I'm going to the office, hey, brew me a coffee, Colombian coffee, and have it ready for me. So it's nothing new, and I think it's really well accepted, and people is doing great applications out of it. It's a really, it's a quite powerful machine for such a small piece. So we are talking about ARM 11 with 700 megahertz. People have been able to overclock up to 1.2, I think. But it's a little risky because once you go over 1, you actually void the warranty. So be careful with that. Just a few information, so it's system on a chip, so pretty much what you have is the chip that you see is not the processor, is that actually the memory, the processor is sitting underneath the memory, and that's kind of designs that they use for, having less space, use less space. What is really important for this particular presentation is the I/O. So you have a lot of features there. You have HDMI and composite video. You have 2 USB ports. That's for the latest Model B. And then you have Ethernet. And then you have the header pins that are, well, is actually where you can actually hook up all the cool stuff. Things like GPIO, Word, SPI, and I2C will be right there. So again, you have both options. You can either use Java SE embedded or you can use Java ME embedded. Again, pretty much for me, the ones that really suit me was Java SE embedded because I thought the UI was more important and I did find solutions for getting connection to the peripherals. As far as I understand from the product team, they are actually looking into included the device access API for Java ME embedded into Java SE embedded. So in the future, I think you don't have to go and bring some libraries like Pi for Java to be able to connect to these devices. So there is something that is being under the table going on to allow to have that library within Java SE embedded. But as it is today, it's not. So extending the Raspberry Pi. So again, as I said, I've been working with the Raspberry Pi, just having a lot of fun with it. And why I2C? Simply because I haven't done anything before. And I just wanted to try. So that's seriously the only reason why I choose that protocol. So I've done something with the Word to get a console attached to get a console out of the Raspberry Pi. We connect different robots using the USB connection. I have connected GPIO to the GPIO, some of the Lego motors to it, and then I haven't done anything with I2C. Before I really move into I2C, a little bit of what we have done with the different protocols on the different pins that you have available. So when you talk about embedded, having a console is actually very useful. Sometimes you don't even have a screen with you and you really need to know what's going on. So having that feature is really important. So we do have Word lines out of the Raspberry Pi, but remember those are TTL levels, so we only get in 3.3 volts. And to be really compatible with RS-232, you really need 12 volts. So you need to bump up those 3 volts up to 12. So you can use, it's actually extremely simple, you can use one of those chips, Max 3232, and that will do the job for you. So pretty much you're taking the Word line from the Raspberry Pi, voltage and ground connected to the chip, and then you can have access to the serial console. You can connect things to the Raspberry Pi using the USB interface. So as long as you connect the device and you can see it, you should be able to talk to it. It will be using things like GNI, and we've been talking inside the product team about GNI, and we agree it's extremely difficult to work with GNI, and that's one of the things that are revisiting and trying to make it easier for developer to use. So it's not easy. We're working on that, and we're hoping to simplify it. For this, it was a robot arm. This was hilarious for me. So I got this robot. Simon was doing some demos with it, and I got into it. Oh yeah, I want to have a robot arm. You know, my 5-year-old will love to grab things and put it somewhere else. Yeah, I have to do it. So I got it on Amazon, and it was a pretty big box, right? So I'm like, okay. And then I was invited to speak in an ARM conference in the Bay Area. And I'm a last-minute person. I have to admit, I'm very last-minute. I'm like, oh, I got the box. I mean, it shouldn't be hard. That's fine. 2 days before the presentation, I opened the box. Because it was big, I thought, oh, the arm is ready to use. I opened, and there were like millions of screws and millions of pieces that I have to put together. I'm like, oh! I ended up working like until 3 a.m. with blisters in my hands, trying to put every screw on it. And the worst thing is you have no idea if it's going to work until you finally plug it in and find out that you can see the device. So it was a very nice experience. Again, when you're using with unconventional software and hardware, those are the things that you expect to find. So again, we use GNI. We create a very simple protocol to control the arms, the base, and the light. It does have a light in front of the arm, so you can turn it on and off. Again, the program wasn't easy. Once you wrap it up into GNI, you ended up having a Java interface, which makes the communication very easy. So again, the beauty of multiple GPIO lines on the Raspberry Pi, so pretty much everything that is green are GPIO available for you. You see number 14 and 15, those are the WART lines that you can use to create the console. And in blue down here, we're going to see that those are the 2 pins for I2C. So we have a data channel and a clock channel that we talk a little bit more in the next slide. And the last thing that we did before moving into I2C was connect a Lego motors. And again, this is fantastic. I created a little airplane that actually moves, being powered by the Raspberry Pi. And again, my daughter loves it. My daughter saw the airplane and the airplane moving, and she was like, Mommy, that's cool. Can I play with that? I'm like, no, honey, that's my job. He looked at me like, Mommy, that's cool. I like your job. So it's a lot of fun. Very simple for connecting the motors. We use dual H bridge, L293. Pretty much you bring the GPIO lines from the Raspberry Pi and connect it to your motors. You provide it with a 9-volt power supply, and that's pretty much it. Again, this was low-level kind of GNI programming, and we're looking into simplify this. Again, we actually didn't really do this. We find a really clever guy on internet. He has a blog about this magic incantation for having access to this. So I2C on the Raspberry Pi. So I2C is a well-known protocol, and as I say, I was finding like a lot of cool devices that use it. And the idea is just simply move data in a simple and quick way from one device to another. It uses a serial interface, and pretty much we're talking about using 2 buses, one for data and one for clock. And we're gonna pass the data along when the clock signal allows us to do so, and we're going to see that. The beauty of this is the master, so it's going to be a master and a slave. The master is the one controlling the clock signal, so the clock rate can vary, right? So different from asynchronous style kind of communication, and it's bidirectional. So it's a multi-master serial single-ended computer bus. It was actually created by Philip. And again, we're going to have 2 open drain lines. One is for data and one is for the clock. And we do normally require pull-up resistors. We do not require this for the Raspberry Pi. The Raspberry Pi that provides those 2 I2C lines already have the pull-up transistor, so they do not require that. And the typical voltage is between 5 and 3.3, so it's actually perfect for the Raspberry Pi. A little bit about the design. So again, so that's kind of how it looks graphically. So you have the SDA line for data, the clock line, and then you have all the slave plugging into those 2 buses and also the master. The addressing that we're going to use for them is 7-bit address. And we have 2 roles, I would say, the master and the slave. The master is the one generating the clock signal that allow you to start and stop the communication. The slaves simply respond to a master request. So we're going to see when the master is going to send this, is going to ask one of the slaves for information, and the slave will respond with it. For the communication again, so we do have the two lines. So we need to have, for any time we're going to pass data around, we need a start condition and a stop condition. The start condition happens when the clock line is high and the master sends a signal on the data channel from high to low, right? So we're talking into here, the master will send a signal high to low while the clock signal is high. So that means the communication starts. Then we pass some data around, and then for the stop communication, it's going to happen again. The master will signal when the communication is finished. The clock line has to be high, and the master will send a signal from low to high. Now, when we want to move data, so we're going to be moving 8 bits at a time, so that's the I2C uses. And again, we're following the clock signal, so the clock signal has to be high. The master or the transceiver will send the data, right? We transfer the data while the data is high, while the clock signal is high. So you can actually send the data every time this clock signal is high, 8 bits. When you finish the 8 bit, you actually need to wait for an acknowledgement from the receiver. So once you send the 8 data bits, you actually have to wait for the acknowledgement that the data has been received by the receiver. So the whole picture of it, so you're going to have a start condition and an end condition. You're going to be moving data along, right? So you're going to have 7 bits, 8 bits of data with an acknowledgement. And the first piece is who is going to respond for the request. So the first piece, if we're talking about who is responsible for answering or who is going to provide the information, so that's the address that we want to do. If we're going to do some reading or writing and against an acknowledgement signal. And then we interchange the data. I actually wanted to leave these 3 slides and talk about it because when I was starting the project, so I have no idea, I never used I2C, and I was getting like, oh my God, what I'm getting into. The good things is with the APIs that we have available, you don't care about any of this communication. So you can actually delete the last 3 slides that I give you. It's good to know how things work, but it's totally hidden to the programmer. And that's the beauty of it. So first, enable I2C on the Raspberry Pi. So again, once I got the idea of the I2C, I knew exactly what chip I was going to use, and exactly, I actually connected on my back of my handmade pad. And then, so I have the sensor here, do all the cabling, and I was expecting to see the device and be able to read the sensor right away. It's not the case. So few things that you have to do to enable I2C on the Raspberry Pi. So that if you go to inside the Pi to EDC modules, you have to add those 2 lines so you can actually use I2C. It's handy to install I2C tools. It's not required, but for me it comes very handy. It allows you to see if you are actually detecting the devices. So I think it was extremely powerful. Then there is a file for the blacklist. So remember that I mentioned so under etc modprop.d, there is a Raspberry Pi blacklist configuration. If I2C and SPI are there, that means they are not enabled by default. So you have to comment out those lines. Okay, so get into the file and take out I2C, and I also took out SPI because I might want to use it too. Once that, you can actually try to see if you can see the device. In this case, so you do I2C detect, either on bus 0 or 1, and you can actually see from the table that I discovered 1 device at 40 and 1 device at 70. Right? So it's actually good to, before you start even programming, make sure that you actually have connectivity, you can see the device. Verify also that under dev directory, you can actually see them. So you should have I2C 0 and 1, and SPI dev also 0 and 1. Okay? If you don't see it, try running again modprop to see if that actually discovered the I2C. So again, few things that when you're trying to do something new that you'd encounter. The board that I use, so this is it. It was 9-axis motion tracking device, and as I say, it's actually pretty powerful. All the information you can get, a little bit more expensive if you compare to the price of the Raspberry Pi, but I still think that $49 is not too bad. It does use the I2C interface, and then you can see here there is one pin is AD0. So this allows you to set the less significant bit of the board to either 0 or 1. So that means you can have two devices connecting to the same bus because you can actually set two different addresses. So you can either ground it or not, AD0 to have 69 or 68 address of the device, and you can connect two of those to the same bus. Again, I only needed one, but just in case you need two, you can actually use that pin for switching the less significant bit of the board. Why I needed an accelerometer and a gyroscope? Why I didn't use just a cheap accelerometer? So if you think about it, what I wanted to do was, okay, I have my device and I want to see when people is moving it around, right? When they're flipping it. So if you think about the gyroscope will give me the angular acceleration. So when I accelerate in an angular, it will actually give me some value. But as I stopped, the acceleration is 0. So the gyroscope is not going to give me any reading once I stop, even though I do have some inclination. So this is when the accelerometer come into picture, because the accelerometer can tell me what is this angle, because it measured the angle against gravity. So I really needed both. I really need to move the screen around as I move the device. But if I was to stop like this, my screen should keep moving because I'm still trying to push the screen to that side. So I seriously needed both accelerometer and a gyroscope. It does have 3-axis compass. I'm not really using it. And then the range, the voltage range is perfect for the Raspberry Pi. So. Connecting things. So as I mentioned, the blue pins are the I2C from the Raspberry Pi. So we have data, we have the clock line. Again, you do not need the pull-up resistors that you normally require for I2C communication because the Raspberry Pi already have those. So pretty much is one-to-one connection. So you just use a cable, solder it, the SDA to the SDA line of the Pi, the clock line to the clock line, get 3 volts, and get the ground also from the Raspberry Pi. And again, just it's up to you to either ground this pin or not. But just make sure you remember that because you will need to know the address that you provide to your device, either 68 or 69. The screen, so I use a Chalkboard electronics, so that's how the screen looks like. I was actually hoping to have the 7 inches screen. I think they still don't have it available. It should be, they should be like either already ready or almost ready for shipping. There's a company in Malaysia, and the screens are not that expensive. I think they are like $149 or something like that. But what's expensive, to be honest, was the shipping. Because it comes all the way from Malaysia, and I think I paid like $50 for shipping. So it ended up being around $200. We do have a discount code, so if you have a Raspberry Pi and want to have one of the screens, you can use that 10% discount. Woodwork. As Simon Reeder always says, a good project has to include woodwork and lights. So this was the first prototype that I did. I mounted everything on a piece of wood. What we have here, so is the Raspberry Pi. This was my first prototype, so I was playing with an MPU board, and I was also using an accelerometer alone to begin with, the ADX L345. So those are the two ones that I was using. We have a light sensor, excuse me, the spelling is a light sensor. You have the screen, so you can still see that I left out the light sensor here. So the idea is the screen should be able to adjust the brightness depending on the environmental light. We do have a touch functionality for the screen. The way it works is it goes, the touch sensor goes to the USB of the Raspberry Pi. Something that I found a little bit weird is when you connect the screen is actually the one that powers the Raspberry Pi. So if you pay attention here, this is the board for the screen that is HDMI connected to your Pi, and then here you have the USB and that goes to the power of the Raspberry Pi. So in this case, the one that has power to it is the screen, and the screen itself is the one that powers the Raspberry Pi. A little bit about the software. So again, Java and I2C for the Raspberry Pi. I was lucky enough to find this library. First, there is a native library that is called Wiring Pi. It's all written in C and inspired by Arduino wiring packages. And it actually provides all the functionality that we're normally looking for: GPIO, I2C, SPI, and UART. It has a command line utility that you can actually use. So it actually allows you to really program the GPIO lines. You can define if you're using the lines for input, output, both, or if you're going to listen for the falling edge, or you do all the configuration for the communication. But still, this is a native library written in C, so we need a wrapper around it, and that's what Pi for Java is. So it's actually providing that bridge between the wiring Pi and the Pi for Java and Java. There are two guys, very clever. I have the opportunity to talk to them. A Java one is Robert Savage and Chris Walls. Those are the two guys that created this library. And I found that it's really easy to use, really simplified, and it works like charm. They actually include a bunch of demos, so you can actually start with their demos. They have a community around it, so there's a whole community for Raspberry Pi. There's Google forum also for Pi for Java, and you have their the address, and they're actually pretty nice guys. You can simply email them, and they will get back to you. They're actually pretty nice guys. Features, so this is what Pi for Java allow you to do, not just for I2C, but all in general. So again, pretty much a wrapper to the wiring Pi library. You can have, for GPIO, you can export and unexport your pins. You can configure the direction. Are you doing input? Are you doing output? The edge detection that you want to do on your pin. You can actually control the state of your pins. You can actually pulse. You can actually read from it. You can listen, so you have listeners, listen for changes in the pin, etc. It also have RS-232 serial communication, so you can actually receive and send data. It has I2C communication, SPI, so a whole bunch of different functionality that you're looking for when you connect peripherals to, in this case, the Raspberry Pi. Again, it's very simplified set of libraries. Installation, so just get the library. It's pretty much straightforward. Just get the API, install it, make sure you do have the files there. And the only thing that you need for your project is pretty much include the Pi for Java into the lib folder of the class path. So just make sure you, for compilation and for running, you include the library, but that's pretty much what you need. Again, there are a whole bunch of demos. So under the examples, you will find demos for pretty much everything. And you can at any moment just uninstall the package and no problem. Small samples about how to get started with these libraries. So I kept one of GPIO sample because I normally start with GPIO. That is a little simple. So this is just connecting a switch to the Raspberry Pi. So you connect it to any of the GPIO lines available. You get the power out of it. It does require a resistor that is not there in the diagram. And then for programming, so this is an example of how you can program GPIOs with Pi for Java. So pretty much what you have is you need to get a GPIO controller, and you do so by getting an instance through the GPIO factory. Okay? Once you have the controller, you can actually declare your input, right? Your GPIO input, and then you define what you want to do. So what is the GPIO that you're going to use? In this case, how you're going to listen. So in this case, we're going to be using pull down. Once you configure, you create it, and then you start using it. In this case, we're actually defined as a my bottom, and you are listening to changes into that pin. So you have a listener to that bottom, so whenever anything happens on this, a state change on the pin, you can listen to it and do something, okay? I2C is actually even cleaner, the interface, when you want to connect. So what you want to do is first you want to get an instance of your bus, right? Once you have the instance of your bus, you need to define the address of the device that you are connecting to. So in this case, did you ground it or not, that AD0 pin, then you get the device. And this is actually kind of annoying, the next two lines, because okay, so everything was ready. I connected the board, I soldered everything, it was being detected, and then I run my program, and I wanted to see some numbers popping up, right? I wanted to sense the movement, and I was getting 0. And the document normally for these boards could be, it's like 300 pages. And all they're talking about is all the different internal registries and all that, all the settings that you need to do. Well, for your board to start sensing, I needed to write 0 on those two registries. So before that, I couldn't read anything. So the problem was this particular board is on a sleep mode. So you have to kind of wake him up and say, hey, I need to start reading. So those are the two lines, right? Start sensing. So in registry 6B and 6C, you need to reset to 0 so it actually starts the reading. Otherwise, you won't get anything. For this particular device, the sensibility of the sensor can be adjusted. So if you think about it with a gyroscope, it's different if you want to sense how fast a car wheel goes and how fast I rotate my screen. I'm not going as fast as the wheel of my car. So you really need to adjust the sensibility for your particular application. So these are the next two lines. So it's actually configuring a little bit the gyroscope and the accelerometer. I don't remember exactly what the 1s and 0 means, but if you take the documentation, it will tell you exactly which bit is turning what. So that's it. And then finally, you can start reading. So very simple, connect to the device that you have, set to 0 those registries, set the sensitivity of your sensors, and then you can start reading. The way it works, so remember in I2C we're using 8 bits, but the values from the sensor are being given by 16 bits. So you actually have to read 2 consecutive registry, put it together, and that's the sensing value that you're getting. Okay? So for the accelerometer data and the gyro data, so we're talking about an array of 6 bytes. So we need 2 bytes for the X reading, 2 bytes for the Y reading, and 2 bytes for the Z reading, and the same with the gyro. Then when you do the reading, there are different ways to read using I2C. So one of the things is you position yourself at the beginning of the registry. Okay, so that's what we're doing here. So this is the first core X value that we're going to get. Then you provide where you want the values to be located, so to be placed. So in this case, we're going to read from this registry. This is where we're going to put the data, and this is how many bytes we're going to read. Because X, Y, and Z and consecutive in this particular board, you can just do 6 byte reading at a time. So this is so you can read it one by one. In this case, we're reading all because they are consecutive. And again, each of them is using 2 bytes, so we have a 16 bit reading for each sensing information. So that's what we do in the pieces here, acceleration X, Y, and Z, is to concatenate both the 2 bytes that you need to read for each axis. Okay, that's not me. I promise that's not me. And then for the gyro, it's pretty much the same thing. So you have 6 bytes that you're reading. The gyro location is 43 registry, and you start doing the reading of those values. Once you have the X, Y, and Z, you just do whatever you want to do. Now, so we know all about I2C, about the devices, how to connect to the Raspberry Pi, now the UI. So I was looking into what to do, and I found this Parallax Principle. And it's something that's not new. It's been around for many years, especially when in the old times of creating games for, for cell phones and stuff like that. And the idea is we see it every day when you're driving around. So think about that scenario. When you're driving in your car in position A, you see like the tree is on the right-hand side of the mountain. As you move on, because the tree is closer to you compared to the mountain, it gives the impression that it's moving faster than the mountain. So when you go in position B, you see the tree in the other side. The environment hasn't changed. What has changed is your perception of the environment, and that's what the principle is about. I found a really nice document, a really nice article from Roman Cortez when he talked about the vantage point. And this is the points where things are moving in reference to. So he has a description of the principle. And what he tried to do is take 2 lines that are parallel to the 3D environment. So he took the 2 green lines against that wall. Right? And, follow the perspective of the 3D environment. With those 2 lines cross, that's where going to be the vantage point there. And then you do 2 perpendicular lines again to your project, to the walls of your, in this case, your scenario, and then make a last line where is the vantage point against where those 2 lines crosses. So this is how things are going to move depending on your vantage point. So the closer to the vantage point, the faster it's going to move. The farther away it is from that point, the slower it's going to move. Okay, so it's pretty much what we're talking about in the parallax effect. For my particular scenario, what I wanted to use was kind of a view of a jungle. So the scenario is very broad, so my vantage point is kind of the infinite in that case. Now, for providing realistic UI, what you need to do is create a bunch of layers. And the layers, again, will move at a different speed. The closer to you, the faster it's going to move. So the more layers you have, the more realism your UI will have. And again, thank you for Photoshop. I couldn't have done it without it. So this is what I have. So I try to have like a plain background, just green and blue, and have a set of sprites that I'm just going to place in the environment at the different layers. And from my program, I'm just going to move the layers around. So this is the result. It's a very long image. And the idea is I should be able to navigate and have an impression of the 3D environment as I move. One of the ideas that I have with this is as you move the environment, you can actually discover things. Because as things move, you're going to see things that are behind. For example, you have a tree and the tree moves. You can actually discover things that are behind the tree that you couldn't see if you are just in front of it. So as you move the environment, you can actually discover new things in your environment. FX sounds like the perfect fit for this. I can have, so it's part of the Java SE embedded, great for UI, I knew it, I love it, great for creating animations, binding capabilities, so I need to bind the sensing information to my UI positioning, so updating the layers was extremely easy. It was just doing a binding to the information I was getting from the sensors. Multi-threading, extremely important. I need a separate thread that is listening to the I2C, and I have another thread that is my UI, and they have to be separate, and they have to be coordinated between them so they can share information. Again, as part of JavaFX, so you have multi-threading using task. So if you want something to run in the background, you just use a task for it, and this is just an example of how to use it. Now, if you want to update your UI from a non-UI thread, then you need to use the run later. So this was a little tricky. Remember, I'm having this thread that is reading the information from the sensors. That's a non-UI thread, and I needed to bind it with my UI. So this is what I needed to do so they can actually do it in a proper way. So just the property for my coordinates in the UI is going to be updated by the angle property of my readings on the screen. Binding, so we all know that we have that beauty of JavaFX when you bind your UI to different values, and then your UI will automatically be updated. So I'm not going to spend much of details because we probably already know that, and it's not the purpose of this particular talk. So this is just an example. My different layers here, the coordinate of the layer, were binding to some information coming in the sensors. And they just move. Okay, so let's go to demo time. Steve, can you help me? Okay, so what I'm gonna do, so I have my Raspberry Pi. So again, this is homemade. You can see screws, you can see a lot of glue, you can see a lot of glue, tape, very robust, very easy access to everything. So compared to the Duke Pad that has a beautiful frame, this has the ability to easily access everything inside, so it has advantages. And well, to be honest, so the FX team was nice with me enough that they actually provide me with Duke Pad, so I can easily just remove my my memories, my SD card and plug it into the Duke Pad. I didn't do it, and the only reason for that is because I positioned my sensor upside down, and I will have to just maybe change and adjust a little bit the code. So I was lazy enough, and I'm proud of my project. So I'm like, you know what? I'm proud of my project. I'm going to keep it that way. So I'm going to power the Pi. For easy connection, I just have a keyboard, so I can type, and I don't have to do any connectivity from my computer or anything. So I'm just going to be lazy and type. So the Pi is coming up. Okay, let me log in. I got 2 demos. I have a small one that allows us to test that everything is actually working. And it's the sensor testing. Sensors. Okay. It takes a while, just while it start. Once we see a mouse, and so it's actually reading, doing some readings. And then hopefully we're going to have a very simple UI that actually allows us to see. So when I move the screen, come on, baby. Okay, it's not working. Hold on. Let me try again. Come on, quit. Okay, demo gods. Quit, quit, quit. Ah, beautiful, beautiful. Hoo-hoo. Okay, so any question while I power this guy again? Try one more time. Let's put it totally flat. Let me just go to the real demo. Oh, Steve, we lost the screen.
Thanks.
Come on, you can do it. Okay, we have the mouse pointer there. Okay, so we do have the UI. So as you can see, it looks like a flat interface, but if I move it around, we should be able to kind of have, you know, different things. You can discover things like the treasure. You didn't see it unless you move it. So you can actually have like moving, and you can go also up and down as you move. I don't know if it's able to. And then you can see here up top, if I move more, like the different layers. So I probably need to create like a, so you can see all the layers behind, and probably need to be like wider so it doesn't, that doesn't happen. But again, it's like the whole idea, there is another treasure there. And I also saw an application on internet. So you can see how as you move things, for example, the tree will get in one on top of another and do like here, like you start getting different shapes. So I saw a game from some Korean guy. Seriously, it was on YouTube. I couldn't understand anything. But the idea that he was doing, he was looking for letters in the environment. So what he tried to do is, as you move the screen around with Parallax, you know, you're going to concatenate some rectangles, and you actually can create like the letters A, B, C, and you can actually select them, and it was kind of a game. So I think it gives you like more realism about, you know, your environment, the position of the user. And again, what I was trying to do is, you know, use some sensors. Again, there are very powerful ones that you can use. And that's pretty much it. If anybody want to come to the front at the end of the talk and play with it, thank you, Steve. If it wasn't for him, I was not able to show the demo. And the other one, I'm not sure why it didn't run. It was just I have these, why it didn't run. It was just I have these two rectangles that allow me to monitor how the X and Y was being read. And then some the conclusions. I love the Raspberry Pi. I think you can do a really cool stuff with it. I mean, once you open the door of sensors, just so many things that you can think of, and you know what you can do is amazing. Java works pretty well. Again, you have Java ME embedded and Java SE embedded is really what you need to work with. And again, have a lot of fun. I think technology is great, it's fun, and it doesn't have to be boring. Thank you very much. You want to come to the front? Yes.
Have you overclocked your RPI?
No, I haven't.
So it's the basic frequency?
Yes. It's out of the box frequency, yes.